Let's go over a couple of practice problems for quiz 4. So to start with here in question 1, we are given this diagram, and we are told that the measure of angle x is 72 degrees. Can we find the measure of angle 1, angle 2, and angle 3? So the thing I'll note first is when we say the measure of angle x, we would use this symbol to denote that, and it's equal to 72 degrees. Angle x and angle 2 are vertical angles. So I'm going to note that the measure of angle x is equal to the measure of angle 2 because angle x and angle 2 are vertical angles. So they must be equal. So that means the measure of angle 2 is also 72 degrees. So the measure of angle 2 is 72 degrees. If I label this in the diagram, this angle is 72 degrees, and so is this one here. So that's this and this, because they're equal. Now, how can I find the measure of angle 1 and the measure of angle 3? They're not vertical angles to angle x or angle 2. Well, this is a straight line. So if you go from here to here, you've rotated 1/2 of a full rotation. A full rotation is 360 degrees, so half of a rotation is 180. Angle x and angle 1, for example, are supplementary angles. That means they add to 180 degrees. So I'll note that, all right, the measure of angle x plus the measure of angle 1 equals 180 degrees. And that's because angle x and angle 1 are supplementary angles. For this reason, in this equation, I can replace this with 72. This means 72 degrees plus the measure of angle 1 is equal to 180 degrees. If you want to find the measure of angle 1, you can take 180 degrees and subtract 72 from it. So what is the measure of angle 1? It's equal to 180 degrees minus 72 degrees. And that means the measure of angle 1 is 108 degrees. So this here is 108 degrees. That leaves us with the measure of angle 3. What is this equal to? Well, angle 1 and angle 3 are also vertical angles. Therefore, these two must be equal as well. So it's got to be that the measure of angle 3 is also 108 degrees. So I'm running out of space here a little bit. I'll say the measure of angle 1 is equal to the measure of angle 3 because they are vertical angles. And that means the measure of angle 3 is also 108 degrees. My answers are, here's the measure of angle 2, here is the measure of angle 1, and here is the measure of angle 3. In question 2, it says, use the Pythagorean Theorem on this triangle to find the missing length. And we are told that this is a right triangle. That is when the Pythagorean Theorem will apply. In fact, it looks like the angle here is the 90-degree angle, and the hypotenuse is always opposite the right angle. We're given that the length of A is equal to 7 inches, and the length of B is equal to 4 inches. I'm going to label those. So on the triangle, this length here is 7 inches, and this length here is 4 inches. This is the missing length. This is what I don't know. The Pythagorean theorem says a squared plus b squared is equal to c squared. If you square the two legs of a right triangle and add them together, it is equal to the square of the hypotenuse. I know whatever the answer here is, it'll be in inches because that's the units I'm using. I'll put 7 in place of A, 4 in place of B, and use this to solve for c. We have a squared is the same thing as 7 squared. B squared is 4 squared. And that should be equal to the length of c squared. 7 squared is 49. 4 squared, 4 times 4 is 16. This is 65. Okay, so this is equal to c squared, and 49 plus 16 is 65. Now that's not our answer. We're looking to solve for c, and it should be in inches. To solve this equation, we can take the square root of both sides of this equation. So we'll say I'll take the square root of 65 and the square root of c. In this case, square rooting something squared will cancel to leave you with just c because these are inverse operations. So on the right, the square root of c squared is c. However, on the left, the square root of 65, well, that's an exact answer. This is something that can be determined by using a calculator. And I'm going to round my answer to 1 decimal place as needed. So the square root of 65 is, okay, I get approximately 8.062. Approximately is equal to c. And if we're rounding that to 1 decimal place, which is here, this 0 will get rounded up to a 1. So that gives us our answer. C is equal to 8.1 inches approximately. And that's the final answer. One other note in this problem, you can also include the units here as inches and here as inches if you'd like. And what happens is if you square inches, you would get square inches here and square inches here. And that would be 65 square inches. But when you take the square root of square inches, it'll drop back down to inches. So feel free to include the units in your work if you'd like to, or you can simply note that in this process, it'll reduce back to inches, which compares to these 2 units here. Question 3 says, license plates in a particular state display 4 letters followed by 3 numbers. How many different license plates can be manufactured in this state? Just to draw something to help me out here, we'll have 4 spaces for letters. So these are for the letters. And then 3 spaces after this for, it says numbers, but I think it probably just means a single digit. It can be a 0, 1, 2, 3, all the way up to 9. So how many different possibilities can we have for license plates? To answer this, I'm going to use the multiplication principle for counting. That is, what I'm going to do is look at each spot and determine how many possibilities can go in each place. Then I will multiply them all together. So like, for example, in the first spot, if we're using letters, you could have something like U, M, A, S, and then you could have 5, 2, 2. Things could be repeated. Well, that means there's 26 possibilities for this spot, 26 possibilities for this spot, 26 and 26 possibilities for these 2 spots. If you want to know the number of possibilities for these 4 places, you would take 26 and multiply it a total of 4 times in a row. So the math looks like this. It's 26 times 26 times 26 times 26. This is the total number of ways that you can have 4 letters in a row. You'll continue and multiply by the number of ways that we can have 3 digits in a row. There's a total of 10 digits if you count from 0 to 9. Therefore, for the first spot, there's 10 possibilities, followed by 10 possibilities, followed by 10 possibilities. When you multiply this all together, that's going to be the total number of different license plates that can be created. I'm going to do this in a calculator. Just to, I guess, save myself some time, this is really 26 to the 4th power. There are 4 of them in a row, followed by 10 cubed. So I'll type this in and see what I get. 26 to the 4th. 26 to the 4th times 10 to the power of 3. And that is a lot. That's a large number. That's 4, 5, 6, 9, 7, 6, 0, 0, 0. Okay, so that is 456,976,000 different license plates. For question 4, we're told a club with a total of 12 members is holding elections for 4 different positions: president, vice president, treasurer, and the parliamentarian. We are further told that each position can be held by exactly one person. So one person couldn't fill both the president and vice president role. So, in how many ways can these positions be filled? There's a couple of ways this could be solved. So I'll do solution 1 and then solution 2. These will be similar. I think solution 1 will be more intuitive. The way I look at this is we are filling 4 positions. So using a diagram like this, you could put 4 spaces in a row. So 1, 2, 3, 4. And we'll use the multiplication principle. We'll figure out how many people could go in for president, then vice president, treasurer, and then the parliamentarian. So starting here, for any one of the positions, there's a total of 12 possibilities. There are 12 members available to fill that very first role. Okay, now we have to fill the next role, but it's not going to be 12. And the reason is one person will already be filling this role here. For this reason, we're going to multiply by 11. There's now only 11 people available for that second role. Moving on to the third position, whichever it is, there's a person filling this role and a person filling this role, so there's only 10 people available for the next role. And then finally, there's only 9 people left available to fill that last position, so this is 9. The product of these things will be the total number of ways that these positions can be filled. 12 times 11 times 10 times 9. Again, I'm going to do this in my calculator. And I get 11,880. That number of different ways, which is quite a few. For a second solution, which ultimately will be equivalent to solution 1, you could recognize this as an NPR question, where N is equal to 12, in this case the total number of members, and R is the number of ways you are choosing them. So this is the number of ways you can permute 12 items chosen in 4 ways. NPR has a formula that depends on factorials. This is n factorial divided by n minus r, then the factorial of that. I will take this information, plug it into this formula, and simplify it. We should end up with this number here. So we'll have 12 factorial divided by 12 minus 4 factorial. That is 12 factorial divided by, that's 12 minus 4 factorial. The top is still 12 factorial, but the bottom is 12 minus 4, which is 8, and then we'll take the factorial of that number. So what is 12 factorial divided by 8 factorial? Well, 12 factorial means you take 12, you multiply by 11, 10, 9, and 8 until you get down to 1. So that is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you divide by 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Notice that 8 factorial can be completely canceled. This 8 cancels with that, 7 cancels with this, 6 cancels with that, 5 with 5, 4 with 4, 3 with 3, 2 with 2, and 1 with 1. And what's left over? The entire denominator is 1, and in the top, since these are all equal to 1, we have 12 times 11 times 10 times 9. So I'll put that this simplifies to 12 times 11 times 10 times 9, which, by the way, is exactly what we have up here for our other way of approaching the problem, which is 11,880 different ways. So this is the answer using solution 1. Here's the answer using solution 2. It turns out they are equivalent. Here, for emphasis, I wrote the numbers going all the way down. But if you understand how this works, you can simply say, well, 12 factorial has an 8 going down to a 1, and 8 starts at 8 and goes down to 1. You could simply jump from this step to this step, so you don't have to write this massive equation down. I put this here for a little bit of emphasis to see how the canceling worked. But that is it for this quiz.